Jitendra sir, can you hear me?
Kajal, am I audible?
Yes, now you are
Yes, sir,
audible.
you're audible. Thank you.
Okay, fine. Thank you. Thank you, Kajal. And yes, on behalf of Department of Economic, Rice deemed to University, I welcome all the participants and especially the resource person, Dr. Krishna Ram and Dr. Ganesh Manji, for giving us their invaluable support for organizing this very important workshop. My special thanks to Dr. Sushanto Biro, who is the research coordinator with the Department of Economics, and also Dr. Faraz Ahmed as a valuable resource person for the workshop. I think as a student of economics, we all will agree that without data analysis, the knowledge of economics is incomplete. So data analysis plays one of the most important part in our education in economics, and especially with the help of the software these days, especially Strata or EUs, and maybe these days R and Python. So I would request the participant to take advantage of this workshop and try to learn as much as possible. This is a wonderful opportunity, and I once again welcome and congratulate each and every participants for coming and enriching themselves. So thank you and welcome once again. Thank you.
Thank you very much, sir. I thank each and every one of you for giving us your valuable time. I also thank the participants for their patient listening. I hope that this turns out to be an enriching experience for all of us. Without further ado, I call upon Dr. Sushanto Biro to deliver his session.
Hello, Susanto. Now you want
Yes.
to take a leave, okay? So now
Okay, sir. Please, thank you. Thank you so much. Okay.
Before that, my hi to Ganesh. Okay, we didn't get time to
Okay.
talk. Okay, Ganesh.
Yes, thank you.
Yeah, see you.
Yeah, see you.
Yeah.
Yes.
See you, Dr. Shushanto.
Yes.
I'm also
Thank
leaving.
you, sir. Thank you. Thank you. We'll meet very soon. Okay.
Okay, so Shanta sir, so we are taking a leave. Thank you so much.
Yeah.
And you
Yeah.
proceed with
Thank
your
you so much, ma'am.
Okay,
Yeah.
thank you.
Thank you. Hope I'm audible to everyone.
Yes, sir.
Yes. Okay. So my topic is around about the introduction to data. Okay. So this topic is the software which is very much essential for our data analysis or data management as well. So this topic is before we entering into the time series analysis or panel data analysis, it is very much required just to understand what is data. And this whatever the introduction to data is, it is basically it will be somewhat a basic introduction, and hope many of you must have learned about it. But again, if something is need to be refreshed, or if something is required to review, so it is very much essential. So therefore, let us have some basic introduction or basic learning of this data. So just I'm going to present to a PPT mode. So please just confirm me whether it is visible or not.
Dr. Biro, your PPT is visible, but you can put it on the full screen mode if you want.
Yes. Yes. So, okay. Now, what happens? This the description of this workshop is: this is an introduction to data, and it is we are assuming that very little knowledge of this data, and we are not going deeper into this, because if we want to start this learning data, then it will take days together. So therefore, it is just to have some basic knowledge. Not appropriate for the people already well familiar with the data. Okay, so it is good and appreciated that if you have already thorough knowledge about this data. But for the people, those who are having little knowledge, or those who want to learn, or just to have how to import data and manipulate this data and put into in an analytical form in by using data, for them it is very much useful. Okay, so familiarize yourself with the data interface, get data and get out of this data. Compute statistics and construct graphical display and compute new variables and transformation. All these things will be covered up here. Okay, so basically when we think of data analysis in the using data, so just we should know why data is more preferred than any other softwares, because it is used in a various disciplines, and it is very much user friendly. So those who know the data, they can handle in a very proper manner. So it is very easy to handle and very easy to remember the commands, whatever is required for our data analysis. Okay, so for the great guides available on different website as well as, so it is different packages also available, and these packages are very cheaper than the other softwares. So it is very easy to install. I hope you must have installed the Stata 13 version, whatever we have sent to you. It is very easy that if you just copy and paste the folder and extract the zip file, then automatically it will be installed. So therefore, this is very easier way of installing or handling over it. And it is, I already said you, this is a reasonable cost, and in a very cheap way we can get. It is also available in the online. We can download it and use it. Stata is like almost we see about Windows icon, syntax, and initial output. And this is in different times of we can get the different versions. Like if you speak about this different edition, like Stata Special Edition, Intercooled, and small for educational purpose. So the different types of Stata edition is there. And when you when the Stata software is installed in your laptop, and you don't need to buy the other one, it is automatically updated with the new edition. So now before I go to the Stata file, just I want to show you the Stata, how the Stata look like. We have up to 17 edition or version today we have in the Stata, but basically I just wanted to show you the Stata 12 and 13 version, because most of the version or edition have a, more or less a similar kind of structure. So similar kind of structure to the Stata 12 and Stata 13. So here, if you can, am I audible to everyone, or are you able to see this all? This what is the presentation is taking place?
Yes, sir.
Yes, sir.
Yeah. So this data is like left side. If you see the history of commands, this window. Before that, I just want to talk to you. There is a write commands here in the below. Okay. Whatever the commands you type or you incorporate, that will be recorded in the history of command, this window, the left side in the top upper side. Okay, so history of commands will be here. Whatever you type, it will be incorporated or it will be installed there, right? If you go below, the files will be saved here. So automatically now the new edition has come, that the files will be saved here. So that is a great impact from the Stata version to that we need not save again and again, but we need to recover this one. So the middle part is like output here, whatever command we type, and the commands, basically the inputs we type and the outputs will be shown in the upper side. Okay, so we can easily point out or easily mention what is the result of the command or what is the objective, our output of our objectives, right? So when we go to the left side, so in the left side, what happens? There are 1 minute. Yes, there are two things like one is variables. We can see in the data file whatever the data is installed or the data is we are using in those data. All the variables will be seen in the left side. In the you can see this arrow mark. Okay, the variables in the data is here, but the description or the property of the variables or the types of the variables will be seen in the downside of the right of this total data structure. So before we go to this data, it is very essential to find out some of the initial level or the first what to do, what not to do. Okay, so when we install data, I think for this new version like Stata 17 and Stata 16, 17, all these things as now we don't need to update the memory, but basically when you are using Stata 12, 13 and all or below that, so we need to update the Stata version or we need to update the memory. Okay, set the memory. So set the memory, it will take you to some extent how many variables you can use that can be that will be useful when you set the memory. Okay, so sometimes if the problem is variable allocation, so by default you have 5,000 variables, but if you want to increase of this, then you have to make set another variable like set max var and up to 1,000 or whatever your choice. You can have a you can put a set or you can have the you can set up the memory. Okay, the status memory. Now if you want to check like after setting up, so if you want to check the how the initial parameters and what is the memory you are having in the Stata, then you can type the query memory and you will get it. Okay, so this is what the initial level we need to do. It is basically when we are using the Stata below 12 version. Okay, so but now it is not required, but for your introduction or for your understanding, I'm just wanted to inform you. Okay, so before we go to the working structure, but using for analytical part, we need to see also to see your working directory. We need to type this PWD. Okay, so this will show your working directory. Okay, and to change this working directory, you need to type the CD. Okay, CD, and also this is also a part of Stata, but not much required nowadays. Different types of saving the file and mode of this has emerged. Okay, now it is very essential to find create a log file. Okay, log file help us. Log file is like a sort of status built-in tape recorder, or where you can retrieve the out of your work or keep a record of your work. Okay, so log file is it will keep automatically the whatever the commands you put and whatever the output you get from this data, it will be automatically recorded in your log file. So when you start working, so it is very much required for creating a log file based on your objectives, like and you name it according to your data file. Suppose if you are creating a log file has to be log using and the name of this your file. So my log is name of your file, and .log automatically comes when you are saving this log file. Okay, this will create the file my log and your working directory. You can read it using any word processor like Notepad, Word, all these things. Suppose any times your battery gets down or anything happens to your computer when you are working, so this all the information whatever you are working will be saved in the log file. So this log file has to be closed when you stop working, like putting log close. This is the command you want to use, then the automatic your file will be closed. And again, when you start working, then again you want to open those. So the below the command is there, like log using my log, the particular name of the file, then you type open. Okay. So is there any changes? Then you need to replace. You have to type replace. When you type the replace using this particular command, which is shown here, then definitely your older option or older data or older analytical part will be replaced by the new one. Okay, so this about the log file. So third thing is that I just want to give you information. There is a do file. It is required. I will show you. I will open the Stata software and I will show you do file. Do file contains a Stata commands. Whatever the Stata command we type here, whatever the Stata command in the right commands here. So whatever we type here, it will be. We need to save the Stata command in the do file, because using this do file also we can start running or start using the Stata. Okay, so this do file is to store your commands, and so to you not to it is the again you should type and redo your work, because if you have kept some commands typed for your analytical or data analysis purpose, you don't need to remember again and again. So you directly go to the do file and open the do file, open your data file, then you start using or start running all these things. So the do file is basically the red arrow mark I have given you. So here is the do file periods. I will also show practically for some times, right? So this is the do file. Already I have said you, and it has to be saved in a particular name based on your data. Okay. Now it is very much useful. I said you the Stata is very easier way of handling, and we don't need to remember all the commands or keep in our memory, because if you type help and the command or command, then how to use the function of the command will be shown to you automatically, and you can learn from there, or you can copy from there and arrange in your data command when you are writing there. Okay, so like example help regress. So help regress means when you are doing the regression analysis, so help regress will show you how this data, how the regress command will be used using different types of variables will be shown, and different example also will be shown to you, and you can code them according to your objectives or accordingly. Okay? So this is a general command syntax that is also in the general command. So when the data is already ready, then we have some option like var list, option, sum. All these things will show you what is the data is about, and what is the characteristics of the data, or how the data, whether it is missing data, or you can easily find out from this common command or general command or syntax, right? So how to start every do file, all these things are being I have already said you. Now the descriptive statistics also almost I have covered all these things. Just I want to show you the practically this is the Stata. Just I want to open. So here what happens, I said you this is the history of the commands. It will be recorded here, and whatever the commands you type here, okay, so this will be recorded in the history of the command, and the variables will be seen here, and there is a below line, the characteristics or property of the variables will be here. So here what happens, I just want to show you some basic concept about this structure, right? So now before we use this data, we need to see this, like this is the file name. It is like a Excel sheet only. Okay. So below that, there are some tabs, like we can see here. This is the data editor. Okay. Whatever the data, this is the do file editor, and this is the data editor. Okay. So this way here we can browse the data. Okay. So this I'm just importing the data. So importing data is like in a different way. We can just you type a edit here. If you type edit here, so there is a data structure. So no data is imported, or no data is given in the data. Okay. So therefore there is a blank sheet is seen here. So we want to import the data in this data form before we use it. Okay. So now here there are different forms of importing the data to the data. So one way is like if you go to the file and there is a import. Okay. So in this import, you go to the Excel sheet. Since my data is saved in the Excel sheet, so I have used this one Excel sheet. So now here I go. Then you go to the browse. Okay. So then you can go to the my data is here, right? So I clicked here. Now after that, there is a worksheet in the data. Since I have saved the data in an Excel sheet, there are different types of sheets available in the Excel sheet. Okay. So I have to choose the which Excel sheet or which sheet I need to use for this analysis purpose, or which sheets data need to be incorporated to this data form. That has to be chosen here. So there are various sheets shown in the Excel sheet. So I choose this sheet. Okay. Then there is two things like import first row as a variable's name and import all data as a string variables. So string and string and the numerical data are available in the data. Okay. So now import first row as a variables. No, I click because in my Excel sheet, the first row contains all the variables name. So therefore I have clicked that one, because you need to click, otherwise you may not be knowing whether which data, which variable is particular data. Okay. So now you go there, then you click here. So your data is shown here. So here basically I can see the data like scrolling like this, or I can minimize or maximize also. Okay. Similarly, the command area also I can do. I can make this bigger or smaller. So similarly, I can do this also. So there is an option, right? So here the data is available, like type of the village or irrigation facility, migration, race, caste, whatever the variables I like, I have shown there. Now I want to see clearly the data, how the data look like. Okay. So I will type, either you click here, data editor, or you can just type edit. Okay. So here the data looks like this. Okay. Types of villages like groundwater village or canal water village, all these things are there. This is the serial number, and these types of village, like whether it is groundwater, canal, all these things are seen. So whatever the data you have in your Excel sheet is being shown here. Okay. So we can easily see this data, right? Now, so before we just to go for analysis, we need to see the property or characteristics of the data. So these characteristics of the data is like I am not going to type all of these commands, whatever is required, but for basic purpose, suppose if I type sum, okay, sum matlab summary, okay, this summary if I type and don't give any variables, then all together it will come. Okay, so all together data, whatever the data we have, everything is kind of like observation, mean, standard deviation, mean, my minimum and maximum we can see. From this we can see that how many observation in race, how many are missing, how many. So altogether 200 observations should be there. But why this 0 and why is less? All these things we can see and clean the data as well. Okay. So this is one way of simple way of explaining what is the data is. Okay. So I already said you create log file. Okay. Now I just want to create log using like your name, like workshop. Okay. Workshop. So this name is saved in NIAP SKV data. This is the path this data is saved. What is the data? The workshop SMCS. Okay. So now whatever the work you do, like summary or regression. Okay. If you put regression, rig is fine. Okay. So in this regression, we can put so many variables. I am putting just at random. Okay. So since observation are not there, so therefore I think it didn't capture, right? So here now, suppose if I want to have a regression, like I want to show you monthly per capita income and something wage rate and something like literacy or something like farm experience. So just I want to see the regression REG. Okay, so I type this one and all these things are there. So REG, I said you it is very easy to handle or very easy to remember the command. So this is what this regression results, and my colleagues maybe they are going to elaborate the what is p-value, what is coefficient, and what is the observation, what is the meaning of this, what is the value, all these things they are going to explain. Now second part, I just want to show you there is a do file. Okay, this is the do file where we need to type whatever like rig command, or we can type summary command and all the variables name, and we need to save this data in a particular way or particular folder. And when we want to use this data or use again or rerun the regression or rerun the data analytical part, then we need to reopen this do file, log file, and we work with that command. Okay, so this is all about my introduction to Stata. Hopefully you must have installed all the Stata which we have I have sent to you everybody, and it is nothing like you just copy the folder zip file and extract it. Automatically your data is installed, and if anyone is finding difficulties in installing, we are here to support you, and I wish all the best. And our objective is to create an analytical structure in your mind, or you should think of about. Now I hand over to Dr. Faraz. Since our data is like panel regression and time series analysis, since our two members of two resource persons, they will be speaking about panel and what is time series analysis using Stata. So before that, Dr. Faraz, I have also requested him, and I also request him just to give an overview of what is panel data, what is time series data, what is the importance of this both, and why we require very much this panel data and Stata or time series analysis. Thank you very much. If you have any doubt, I'll wait for 2 minutes. Otherwise, I will just hand over to Dr. Faraz.
Good afternoon, sir. I have
Yes.
some doubt. Sir, the command that you have used, that is regress, and then you have selected few variables. So the first variable in your example, that is MPFI, that will be considered as dependent variable or independent variable?
Yes. So just, 1 second, I am just opening. Okay. Yes. So here what happened? Just suppose if I type a rig, no, so regression, I have already typed this one. Okay. So here the first one is a dependent variables we consider. Okay. And rest of them are independent variables we consider. And basically, but the rest, when we talk about rest, means leaving this first one, the second one will be talking about the main independent or the treatment variable we consider normally. But even if you put these variables in a different position, the second one, the result will be same. Suppose if I put these variables like here, okay, so this result will be same like what is it, WRL minus, and here also WRL minus. Okay, so but the first one is a dependent variables and rest of them are independent variables.
Sir, one more question. Can we use this data for the survey analysis as well?
Yes, the for the survey analysis data, you need to update the data and install. If you there is a suppose any command like a regression command, no? Suppose regression command is not running here because new version has not updated. Okay, so similarly for the survey data, you need to install using SSC install and that particular survey, something like that. Okay, so maybe I'll be sending you if you want that file. So you need to install that. Then for your survey data, it will be much worthful.
Okay, sir. Yes, sir. Please share that.
Yes.
Thank you, sir.
Thank you. Okay, so I'll be handing over to Dr. Faraz. And Dr. Faraz, kindly go ahead with your.
Thank you very much, Dr. Biro. Thank you for your nice explanation of basics of Stata. I hope the participants must have, those who are new to Stata, they must have learned how to begin using Stata. Well, I'm here to support the other two speakers who would come and talk about, who would come tomorrow and the day after tomorrow in the coming 4 days, and they will talk about panel data analysis and time series analysis. My role, as Dr. Biro asked me to do here, is to give a kickstart and help the participants to get acclimatized and used to the basics of the regression analysis. And I was asked to focus on those people who are new to econometrics and who are new to time series and panel data methodologies. So that is what my goal here is going to be in the next 1 hour or so. And I want all of you to keep writing in the chat box if you have a doubt in whatever I am talking, and I will read from there and try to answer the queries. One question that I would like to ask upfront is that how many of you are familiar with econometrics, the basics of regression, the method of ordinary least squares, the interpretation of the coefficients of a multiple regression model, the assumptions of the classical linear regression model, the problems in the estimation. So if all of you are okay or familiar with these things, please let me know. Or if you want me to throw light on some of these things, I can do that. I can focus on that topic a little bit more, which you write in the chat box, apart from my usual presentation that I've made. That will that would cover all the basic topics with respect to regression, cross-sectional regression. And later on, I will introduce you to the basics of time series analysis, or data, I should say, the cross-sectional, the panel data some problems which are peculiar and specific to these types of data. So I'll come to that later. So what I want from you is that you should keep writing in the chat box, so that I am aware that who I am talking to and what I am dealing with and what I need to focus on during this 1 hour, because my goal is to prepare you for the coming 4 days, right? So please do not hesitate. Any one of you, it's your time. You can tell me that uh, where I should focus more. Of course, I'll be doing the basics only. All right. So it, it is written in the chat box that it will be helpful if you cover all the topics, basic topics, even in OLS. I know the basics which you mentioned, but if you could throw more light on it, so I'm new to it. Please keep writing. When I get few more, I'll plan accordingly. At least each one of you should write something, one line at least, so I know where we stand. It will be good for me as a trainer here. Please continue. So I'm getting mixed answers. Some of you are writing that you are aware of things but need a revision. 2-3 people have written that they need a revision. They are aware but they need a revision. 2-3 people have written that please go through the basics. 2-3 people have written that you are completely aware of these things. It will be helpful if you cover all the basics. I know the basics, but if you could throw more light into it. I'm just reading the chat, what is there in the chat box. Please explain multivariate time series analysis and its issues. So multivariate is going to be the explained in detail by the expert. A hands-on approach on the basics will be useful. Okay. Quick revision would be better. Okay. Right. So I got some idea. Some of you want me to go through the basics well. Some of you are aware but need a little bit of revision, a quick revision. So we don't have that much time also. It will definitely be a quick revision. Uh, Multivariate time series like vector autoregression or error correction models or Arch and Gart models, those will be taken by the experts. So I'm not going to go into those issues. Okay. Right. So this is enough for me. And please keep on writing so that I understand. Hands-on experience on stationarity. Okay. So I'll talk about stationarity also, because it is written in the chat box. Although I'll not do the tests on Stata because that would be a part of the experts lecture. So I don't want to do anything which they are going to do. I just want to stationarity, etc. I'll explain because someone has written it. All right. Okay. So let me share my presentation. Please keep writing in the chat box so I am aware where I am. You can raise your hand or you can ask the question in the middle also. But it's better to avoid it unless it is extremely necessary. Better to write in the chat box. But still, if you want, you can ask. I believe my presentation is there and you can see it. So let me start with the measurement scales. There are 4 scales on which we can measure the data. These are ratio, interval, ordinal, and nominal. So when we do data analysis, we come across variables which are nominal. That means those are names like gender. It has those have categories like male and female, uh, like race, black race, white race. So race, if you have a variable like race, like gender, it's going to be a nominal scale variable and it is measured on the nominal scale. Ordinal scale is the one in which these categories have a normal general ordering. For example, if you have a variable called grades, there will be 3 or 4 grades, A, B, C, D grades of students. And these are ordinal in the sense that A is better than B and B is better than C and C is better than D, which was not the case with nominal variables, because you cannot say that white race is better than black race, or male comes ahead of female. So that's the difference between nominal and ordinal scale variables. Both are categorical, but there is a subtle difference. Then we have interval scale and ratio scale variables. These are quantitative variables. They are measured on ratio scale or interval scale. There is not much difference except that uh, for a variable to be measured on an interval scale, uh, the ratio may not make sense, but the distance does make sense. For example, if we have time in years, so the year 2000 and the year uh, 1000 years back. So if you take the difference between the two numbers, 2000 minus 1000, it is 1000 years. So this distance makes sense because the year 2000 is 1000 years ahead of the year 1000. But if you take the ratio 2000 divided by 1000 and the answer is 2, so this ratio doesn't make sense. You cannot say that the year 2000 is twice as the year 1000, right? And it generally happens because there is some origin, and when we talk about time, the origin is not 0, so you cannot say that time started from 0. Then the last is ratio scale. This is also quantitative. We have numbers uh, which are measured on a continuous scale. So ratio also makes sense. That means, for example, if I have got 50 marks in a test and somebody got 25 marks, I can say that I got 25 marks more than that person, and I can also say I got twice the marks that he got. So ratio makes sense. So these type of variables are ratio scale variables. So we can measure all the different variables in the world on these 4 scales: ratio, interval, ordinal, and nominal. As I said, you can ask question in the middle. Please do not hesitate to ask anything, whatever comes to your mind. I'm going a little bit fast because I have to cover a lot and I have got just 1 hour. Right, so whenever we do regression, why do we do it? What is this regression all about? Actually, regression is a method of association, establishing some sort of causation or association between different variables. And by the literal meaning, regression is a sort of slow movement, right? So we are interested in knowing the movement. Whenever we do some analysis, we have some population in mind and we work on the sample at hand. There is a difference between a population and a sample because a sample is a subset of population. So when we are running a regression, that to a linear regression, we are trying to fit a line to our sample data. And we have in our mind that there is a line that exists with respect to the population data. We call it population regression function or population regression line, as you can see on the screen. Let me write regression equation here. So suppose we have a linear relationship between y and x, and the intercept is beta 1 and the slope is beta 2. The explanatory variable is xi, and the equation for this line is written as expected value of y given x. This is a population regression line, and it established the relationship between two things: expectation of y given x and the values of x, where x is the regressor and expectation of y given x is the regressant, right? These are not the actual values of y. The actual values of y in the data which are there like this. If you want to see the relation between y and x, then you have to write yi equals expectation of y given xi plus ui, where ui is the error, right? And this is the conditional mean of y given x, and this is the actual y, right? So that takes us to the error. So I'll talk a little bit about the error. This is also called the disturbance term. Why do we have it in regression? That's the question. There are various reasons for it. We have error term or disturbance term in the regression because sometimes our theory is vague. Sometimes whatever relationship we are expecting between y and x is not true. There might be some other theory. There might be some other axis. So due to no clear theory, we should have some sort of compensatory variable in our equation, and that is done by introducing the error term. Sometimes data is not available, so in order to compensate for unavailability of data, we use the error term. Sometimes we cannot include all the important variables in the model, or we want to include only the core variables, and we don't want to include peripheral or less important variables in the model. So that adjustment is also done through the error term. Human behavior is random, so that randomness cannot be explained by any variable, so we need the error term. When we use proxy variables, again, proxies can never be as good as the original variable, so we need some error term in the model. Then parsimony is important because we want to keep things simple. We don't want to complicate things. To keep things simple, we approximate some of the complexities in the model through error term. And sometimes we make mistakes and take the wrong functional form that forces us to have an explicit error term in the model. Generally, we say that for whatever variable we cannot include in the model, we have adjustment mechanism through the error term that builds or makes up for those missed variables. So that's the importance of error term. We must have it in any regression, as I showed here, and these are the reasons why we need the error term in any regression model, be it cross-sectional, be it panel data regression models, be it time series models. You are going to face this error term every now and then. This error term will become even more important as you make your analysis more and more sophisticated. I will not say complicated, more and more sophisticated. It is critical to understand why and how and where this error term is entering into the model. Why is it there? What does it mean? To understand those sophisticated regressions, which you are going to see in the next 4 days when you do the fixed effects model or the random effects models, or different panel estimators like within group estimator or pooled estimator. is it is very important in time series econometrics also, because it is the error term through which you will understand the concepts of shocks, and the effects of shocks, the impulse response functions, and simultaneous equation models. The understanding of the error term is vital. So this is just a basic explanation from my side, that why do we have this error term in our model. So sample and population are two different things. We will never know the parameters of the population function. What we have is the sample, and it is statistics that is coming into play, that we are able to say something about population just by using a small sample out of that population. So a lot of statistics that connects the sample to the population. If you have any questions in these concepts, you can ask. Then I'll move forward to the assumptions very, very quickly. Okay, at this time, let me go back and see the chat box if any one of you have written anything there. Okay, nothing there. So let me come back to the assumptions. All right, so we are in the framework of classical linear regression model. The first assumption about our population is that we assume that our population regression model is linear in parameters. So we are not dealing with nonlinear in parameters model. We are doing a line fitting exercise. We are having a linear relationship between our explanatory and the dependent variable. That's what we assume when we go for a classical linear regression model. We assume that x values are fixed, or otherwise, if not, then they are independent of the error term. It means that the covariance between the x's and the u's is and the error term is 0. It means that this means that our errors are random, right? They don't depend on the axis. There is no systematic relationship between what errors you are getting and how the values of x is changing, right? So we need this assumption. If this assumption is violated, we will have problems in our regression. Or otherwise, we assume fixed x values. Fixed x values simply means that we are sampling repeatedly for given values of x, whatever they are, so that we have multiple y values for a given x value. And then we can do the line fitting exercise on this data rather easily. And if we assume our x not to be fixed, then we have to assume that x values are independent of the error term. Zero mean disturbance of the errors. It means that the positive and the negative errors cancel each other. That means the regression line is so good that it passes through the data right from the middle, so that it divides the y values vertically into two halves, where there are some positive errors and some negative errors, and they cancel each other out, and conditional mean of the errors is 0. That means for each x, the mean of errors is 0. So that is the expectation of ui given xi being 0. Another assumption is homoscedasticity. It relates to the variance of the disturbance term. We assume that the variance of the disturbance term, the conditional variance, is constant. It will be very difficult to do predictions or to do forecasting or to make out of sample predictions if the error variance is not constant. It is very important to satisfy this assumption that the error variance is constant, because then it imparts some predictability to our regression. So we can talk about out of sample values uh, on the basis of the sample that we have. So the assumption is simply constant variance assumption of the errors, and it is known as homoscedasticity. Another assumption is no autocorrelation between the disturbances. It means that for when we run our regression, whatever our disturbances or errors are, there is no systematic pattern in the errors. They do not depend on each other. We cannot predict the upcoming errors on the basis of the past errors or past use. So we need to assume that there is no autocorrelation between the disturbances. And this assumption is very important for time series data analysis, as you will see, because in time series you will be looking into the autocorrelation functions and partial autocorrelation functions to decide on the models, and the behavior of time series is caught or captured by understanding their autocorrelation functions. So the term autocorrelation itself tells us that it is nothing but correlation of something with itself, autocorrelation. So here in this assumption, it is about the errors. So if errors are correlated with themselves, there is some predictability in the errors. We are not good to go. We must have our errors which are not autocorrelated. Then assumption number 6 and 7 are simple, and it just says that we should have enough sample size, assumption number 6, and assumption number 7 simply says that our x variables, they must not all be the same. So there should be some variability in the x variables, which is also the explanatory variables. Assumption number 8 is no multicollinearity. Multicollinearity means that our regressors or our x's are not correlated with each other. The reason for this assumption is that if our x's are correlated among themselves, for example, there are two x's, x2 and x3, and they are correlated with one another, then it will be difficult for us to single out the effect of x2 on y and the effect of x3 on y. If you want partial or clean effect of x2 on y and clean effect of x3 on y, then it must be the case that there is no effect of x2 on x3 and there is no effect of x3 on x2. So they should be completely uncorrelated. There should be no exact collinearity between the x variables. I have prepared these slides from Gujarati. Those who have read Gujarati must be understanding the slides very well. So it says that the perfect collinearity between two variables occurs when this equation lambda 2x2 lambda 3x3 equals to 0 is satisfied, which means that x2 can be completely generated from x3. If we multiply each x3 by -4, we will get our x2. It also means that our x2 does not contain any new information because we can completely get it from x3. That means we do not have two different variables, x2 and x3. Actually, we have one variable, not two, because one can be had from the other. This is the result that happens when there is perfect collinearity between variables. So we need to fulfill this assumption, because if this is the case, we will not be able to estimate the parameters of our model. As you can see here in this slide, that if you can replace x3 by 2x2, as you can see here, in place of x3, if you write 2x2, then what you are estimating is this regression, beta 1 plus alpha x2 plus ui, where there is only one parameter alpha that would be the result, but not two parameters like beta 2 and beta 3, right? In fact, alpha is equal to a combination of beta 2 plus 2 beta 3, and this is one equation, and it has there are two unknown, there are one equation and two unknowns, and you cannot get both of them. So it is impossible to get beta 2 and beta 3 when there is perfect multicollinearity. How do we interpret a multiple regression? If we have a regression equation like this, yi equals to beta 1 plus beta 2 x2 plus beta 3 x3 plus ui, then beta 2 measures the effect of x2 on y, beta 3 measures the effect of x3 on y. The value of beta 2 tells us that what would be the change in y for a unit change in x2. The value of beta 3 tells us what would be the change in y for a unit rise in x3. So if x3 rises by 1 unit, how much y will change is beta 3, and for a unit rise in x2, how much y will change is beta 2. So these are partial regression coefficients in the sense that these coefficients beta 2 and beta 3 tell us clearly the individual or clean effects of x2 on y and x3 on y. Another important thing when we do regression is to understand the standard errors. So in any regression output, you will see the coefficients and you will see the standard errors. What are these standard errors? Standard errors are of any regression coefficient or OLS estimates are basically a measure of variability or variance of that particular coefficient. If we think of repeated sampling and if we calculate the coefficients from all possible samples of the same size from a given population, then you will have many different coefficients, and if you calculate the variance of those coefficients, that would be known as if you take the square root of that, that would be known as the standard error of that particular coefficient. So standard error is simply a measure of variability or variation of the coefficients or the parameters of the model, the betas, right? So it is critical to understand the concept of standard error for a very simple reason. If you think intuitively that you have collected one sample from a population, a big population of say 10 lakh, and you got a sample of 100, and you got some value of beta 2. It is by chance that you collected that sample of 100. If you do it again, you would not get the same 100 observations again. You would get another 100 observations. If you do this process again and again, every time you will get a different sample. From all those samples, if you calculate your beta 2 hat, all of those beta 2 hats will be different from one another. So which one is right? Which one is correct? So there is no straight answer to this question, right? So there is some chance or some uncertainty or some probability involved in it. So for that, we need a probability distribution. So we try and develop a probability distribution of the beta 2 hat, and the variance of that probability distribution or that particular beta 2 hat values, and the square root of it, which is the standard deviation of it, is nothing but the standard error. So what we are getting from standard error is a connection between the sample and the population. That makes this concept very, very important to understand if we are interpreting regression results. Because in every regression output, you have coefficients and then you have their standard errors. So you would read those standard errors as being a connect of your sample to the population. Like I want to point out one or two things in the formulas here, because if we understand it, it will help us a little bit in understanding bigger concepts. If you see this second formula here, standard error formula, this one, point number one is that for a given value of sigma squared, the larger the variation in x values, the smaller the variance of beta 2, and hence greater the precision with which beta 2 can be estimated. It means that if this value is taken to be given and constant for a given sigma squared, larger the denominator, larger the variation in x, smaller the variance of beta 2 hat. Smaller the variance of beta 2 hat means more precision. More precision. So we are able to estimate our beta 2 hat with more precision if variation in x values is more. So that gives us a reason to believe that we should have variability in our x values. Now, second thing is that if for a given variation in the x values for a given denominator, the larger the numerator, that is larger the sigma squared, larger the variance of beta 2 hat. That means if the denominator is given and if this sigma squared is high, what is this sigma squared? It is basically the RSS divided by degrees of freedom, and RSS is the residual sum of squared, which is the square of the deviation of the residuals, square of the residuals, right? Residuals are just the deviations of the actual y's from the estimated y's, right? So that's why we need a bigger sample size, because if we have a bigger sample size, this denominator will rise because summation xi squared will rise, and then we will have smaller variance beta 2 hat and smaller standard error. Smaller standard error means more precision. So it highlights the formula itself highlights the importance of a bigger sample size. Another important thing is Gauss-Markov theorem. You all must have remembered in your basic classes of econometrics that the OLS gives such estimators, beta 2 hat, beta 3 hat, beta 4 hat. These estimators are in the class of all unbiased linear estimators. They have minimum variance, right? And having minimum variance is important because it directly relates to the precision, and we all want to be precise in our estimates. So we need low standard errors, we need minimum variance estimators, and actually OLS estimators, the ordinary least squares estimators, are the minimum variance estimators. So Gauss-Markov theorem simply tells us that we need to have linear, unbiased, best estimators, and OLS estimators are indeed linear, unbiased, and minimum variance or efficient or best estimators. I am saying again and again that I will stop by a topic if you ask anything from it. Otherwise, I will be moving forward, right? So if it's you feel free to ask anything from wherever you want. So I'll explain a little bit more. I'll stop there and explain a little bit more if you ask anything from there. Right, so let's come to our main topic. time series, cross section, panel data. So what is this all about? Basically, in time series, we observe the values of a variable over a period of time, as we all know. And in cross sectional data, we uh, take a variable's values at a point of time, but we take it across different cross sectional units or sample units or subjects. So this word subjects is important because I think it will be used heavily when you will be attending your panel data sessions, because in your panel data sessions you will come across terms like subject specific variation or or time specific variables or time invariant variables or subject invariant variables. So subjects are like cities, states of of the United States of America. Subjects can be individuals living in a village, households in a village. Subjects can be countries of the world. Subjects can be firms in a given geographical location. So these are subjects or sample units. So cross-sectional data is collected across subjects, but at a point of time. Time series data is collected for over a period of time, but for a given subject. So that subject can be a country, it can be a city, it can be an individual, it can be a class, it can be a firm, any entity. So this is the basic difference between time series data and cross-sectional data. The third type of data is the panel data. Panel data is a mix of time series and cross-sectional data. If you collect data not only over time, but also across subjects, then your data is panel data because it has both the dimensions. It has a space dimension and it has a time dimension. So panel data is in this sense a mixture of both time series and cross-sectional data. So it has both the characteristics. In fact, this is the reason why we need to understand a little bit about time series and cross-sectional data to be able to get the panel data techniques. So I'll come to panel data, but let me start with time series. All of these extracts are from the basic econometrics book, basic econometrics or introductory econometrics by Gujarati. So one thing we need to understand with respect to time series analysis is the stochastic process. So if you most of the people are familiar with cross sectional data analysis or cross-sectional econometrics, where we have a concept of a sample and a population. A sample is a small subset of population. For all the econometric or statistical analysis, we have a population and we have a sample. And we consider both of them. We use the sample data and we try to say something about the population on the basis of the sample data that we have, right? That's typical cross-sectional way of looking at things, right? Now let us adapt this concept to time series. Suppose we have a variable called GDP, and we have collected the values of GDP from period 1 to period 100. So we have 100 values of GDP spread across 100 time periods, one GDP for each time period. This data that you have, what would you call it? Would you call it a sample? Or would you call it a population? What would you call it? Anyone? Any answer? You have got a GDP series, 100 years for India, the GDP of India from period 1 to period 100. So 100 values of GDP. What is this? Is it a sample? Or is it a population? Anyone? All right, so let me explain. Actually, it is a sample. So you might ask me, if it is a sample, then where is the population? Right? So this is exactly what we need to understand. The very basic, the first topic in time series is just to understand what is a sample and what is a population. So basically, a stochastic process is the population, and a stochastic process is a collection of random variables ordered in time. And uh, when we have different stochastic processes, like GDP is a stochastic process. When we are bringing it into time series analysis, like disposable personal income is a stochastic process, value of stock is a stochastic process, electrocardiogram is a stochastic process. So uh, actually, GDP in of India, suppose it is 100 in say 2020, and it could have been anything, but it turned out to be 100 when we passed 2020. At the end of 2020, we calculated the GDP and we found that it is 100. So that is one realization of many different possibilities which could have happened, right? Out of many different possibilities, one of those possibilities got realized, and that is the value 100. So what we got in our sample is a value 100. It could have been another number, but it is realized to be 100. So a particular sample values that we have, in our case the 100 GDP values of India, they are all particular realizations out of many many different infinite possibilities which were there. So that is a sample in that sense, and all possible realizations together comprise a stochastic process, right? So that all different possibilities is the population, and what we picked are particular realizations, and that is a sample, right? So in this way, we can differentiate between a sample and a population, which is, in case of time series, is the difference between the realizations and the stochastic process. So we pick a realization from a stochastic process as we pick a sample point from a population in cross-sectional data. In time series data, we pick a realization from a stochastic process, right? So it's critical to understand that we have a concept of population and sample in time series also, but although it is known with different names, so it is very much there is one-to-one relationship in terms of the conceptual understanding or conceptual part of it. Another thing, as someone also asked, that what is a stationary stochastic process? So, of course, the tests of stationarity or unit root tests, etc., will be covered when you will go through the time series analysis. Those experts will be dealing with the details of it using state, of course. I am only here to discuss a bit of building blocks or some theory to build upon that, to just make you to just revise a few things for you, so that you are there with the resource person in the coming days. Okay, so stationary stochastic process is is that process which has a constant mean, which has a constant variance, and which has a time invariant covariance, right? So suppose there is a series yt. This is the time series, and if we are talking about the stationarity or weak stationarity, so I'll talk about a little bit more about weak and strict stationarity after this. Right now you can think of stationarity, don't consider weak. Stationarity definition is that its mean, the expected value of yt, should be equal to mu, which is a constant. So there should be no change in mean in the series. So uh, the mean of the series should remain constant with time. As time passes, the mean of the series should be same, mu. It should not change. That series will be a stationary series. That process will be a stationary stochastic process if we talk in terms of population. The variance should be sigma squared. That means variance should also be constant. So it means that the series should not have unequal variance as we move, as we go through time. Its variance should be constant and it should be equal to a number, and that number can be called as sigma squared or whatever you call it. It's generally known as sigma squared because this is the notation for variance, right? And then the third point is covariance. The covariance should be should uh, uh, the covariance between two time periods should depend only on the distance or the lag between the two time periods. So let's take two time periods. So I'll focus a little bit on this covariance part because this is a little bit tricky. It will help you understand this example. So there is a measurement of y at time t, and suppose you create another series with a lag of k or k periods apart, another y, the same y. So y is GDP, this is yt, GDP at time t. Again, we have yt plus k, which is also GDP, but it is at time t plus k. So the difference between the two series is k. They are k time periods apart, right? So if we are talking about the stationarity of the y series, then it should be the case that the covariance between of the series y should depend on k, right, and not on the actual time at which it is measured. So suppose k is 3, suppose, then covariance between y2 and y5 and the covariance between y3 and y6 will be same. If you make a series y2 and you make a series y5 and you calculate the covariance, suppose it is 0.5, and you take a series y3 and you take a series y6 and calculate covariance, it will, if it is also 0.5, then we will say that this series is covariance stationary, right? So covariance, if it depends only on k, which is the lag, then we have a covariance stationary process, and that covariance is denoted by gamma k. Gamma k. This gamma k is the covariance, right? And it is the expectation of the yt minus mu, that the deviation of the series from the mean of the series, and deviation of another series yt plus k, which is k periods apart, and from the mean. And we know the formula for covariance, This is the formula for exactly the formula for covariance between two variables, right? If this is also constant, right? If it depends only on the lag, right? Then we say that the series is covariant stationary. Otherwise, it will not. So this is how we define stationarity. Understanding constant mean, constant variance is easy and simple. A little bit of attention is required to understand the covariance stationarity. Coming back to weak and strict stationarity, this is the definition of weak stationarity, and it suffices when it comes to time series analysis. So, whatever analysis you are going to study, this type of stationarity will suffice. Strict stationarity is a little bit broader concept in which we talk about not only about mean and variance, but also about other moments of any series. So we don't need that much similarity. What we need is only weak stationarity for time series analysis, and that would suffice, I believe.
Excuse me, sir.
Yeah,
Generally, I got confused between the terms variance and covariance. Can you give an example so that it can quickly directly go into my mind and I can get the difference between variance and covariance and
definitely,
relate them also?
definitely. Very good question. So, uh, when we talk about variance, uh, we are trying to have a measure of how much variability is there in any particular series or any particular variable yt, right? Suppose there is a variable y whose values are 2 3 4 2 3 4 2 3 4, right? So values are quite close to each other. And we have another variable called x, and its values are 2 10 15 18 25 30 3 12 1 0. There's a lot of variability in these values, right? So we will say that the variance of x is very high, while the variance of y is very low because values are close to each other. So that's the meaning of variance. How much variability is there in the data? Did you get it?
Yes, sir.
That's the
Okay.
variance, right? That's the variance. When it comes to covariance, we are talking about two variables, right? Not one, two variables, two different variables. And we are trying to see whether the two variables, A and B, whether these two variables are moving together, right? For example, if A goes, suppose the values of A are 2, 3, 4, 5, 6, 7, 8, right? And the values of B are 12, 13, 14, 15, 16, 17, 18. So what we see is that when A is rising, B is also rising, right? That means there is very high covariance between A and B, because when A is rising, B is also rising, right? It can also be the case that the values of A are 2, 3, 4, 5, 6, 7, 8, and the values of B are 8, 7, 6, 5, 4, 3, 2, 1. Again, there is one-to-one correspondence, because when A is rising, B is falling. But there is co-movement. They move together, although in opposite direction, but they are moving together. There is very much coherence or co-movement, although in negative direction, but co-movement is there. Again, we will say that there is very high covariance between A and B. Covariance will be zero if we have sort of random numbers. So I'll write that example here on the slide. Suppose you have a variable A and you have a variable B, and then this variable A has numbers 2, 0, 1, 5, 6, and then there is another set of numbers 5, 10, 6, 4, 3. So there is no set of movement, co-movement in A and B. See, when A goes from 2 to 0, B goes from 5 to 10. So this is falling and this is rising. And again here 0 to 1 rising and 1 to 6 falling and 1 to 5 rising and 6 to 4 falling. And there is just no coherence. It's sort of randomness which is there in these two variables A and B. So we will say that covariance between A and B is very low, like 0. Right? So variance is about a particular series. How much variability is there in that series? Is it very much variable or is it not that much variable, sort of constant? That number, the variance sigma squared, that tells us about how much variability is there. Covariance is sort of relationship between two variables, right? Whether they are moving together co-varying or not co-varying. So covariance can be positive if they move in the same direction. Covariance can be negative if they move in opposite direction. Covariance can be 0 if they do not move together at all. I think I answered what you asked.
Yes, sir. Sir, then the covariance situation will exist in the time series when we have two or more series.
Yes.
Is it so?
Yes. Very good question. Again, let me clarify on this. Actually, what we see here is one series only, Y, right? But you can create another Y series by lagging the original Y series. So let me very quickly show you how that can be done. I'll take only 2-3 minutes for answering your questions for this question, but I need to. Okay, do you see the blank slide on my screen now?
Yes, sir.
So suppose my GDP series YT is 25 minus 1, 0, 3, 6. Oh, so it should not be GDP because GDP cannot be, oh, it can be negative in very strict sense. Anyways, suppose this is our YT series 25 minus 1, 0, 3, 6. So this is YT, right? What about series YT minus 1? So if you write 2 here, because 2 was the last value, one period before the value was of GDP was 2, right now it is 5. If I write 2 in front of 5 in just below YT minus 1, so this is the value of YT minus 1. The current value of Y is 5, the one period lagged value of Y is 2, right? Similarly, you can write a 5 here, minus 1 here, 0 here, and 3 here. Now you got two series number 1, series number 2, right? Series number 2 is again the same Y series, but it is one period lagged Y series. Series number 1 is the current Y series. So you can think of covariance or covariance between YT, comma, YT minus 1, right? You can calculate it now because you have two different series as two different variables. Although it's the same series, but one is the lagged value of the other. In this sense, we are talking about this last third stationarity, covariance stationarity definition. Did you get it?
Yes, sir. Yes, sir. Thank you so much, sir. Very
Okay.
good explanation.
Okay, thank you. All right. I think I have only 12 minutes remaining, so I'll go a little bit fast. Okay. Any time series has this quality of mean reversion. So when we said stationarity, we were talking about this series which is going like this, and it's sort of staying somewhere here. So we have a sort of constant mean mu, and we say that this is a stationary series because it is not moving wayward. So it's not going like this, there and there everywhere. No, it's sort of staying around mu. So this is called mean reversion because any series, if it generally tends to revert to its mean, right? Another question that you will see when you are studying time series analysis, your resource person will talk about these terms, that this is mean reverting, it reverts to the mean quickly. Some series revert to the mean very quickly, some series revert to the mean after long times. So there is a distinction between these sorts of time series. Accordingly, the analysis part is done. Anyways, mean reversion. What I want to tell you is that there is something called mean reversion, and a time series which is stationary has a tendency to revert to its mean very quickly again and again. Okay, let me talk about panel data because we have only 10 minutes very quickly. As I said, panel data has both the characteristics of cross-sectional data and time series data. It has a space dimension and it has a time dimension also. So why panel data? Because you can always break the panel data into different time series data, and you can do time series analysis. You can always break your panel data into various cross-sectional data sets and then do cross-sectional analysis on each of those, but we don't do it. We go with a specific type of analysis which is known as panel data analysis. So why do we do it? The reason is, number one, that when we have panel data specific to firm, state, countries, or whatever subjects you have, there is bound to be heterogeneity. Heterogeneity means there are going to be subject specific characteristics, right, or uniqueness in these subjects, right? So panel data techniques help us to take such heterogeneity explicitly into account, and we are able to see these subject specific variations with these specific analysis very well. Point number two is that when we combine cross-sectional and time series together, we get panel data, and it is more informative. It is more informative. Think about uh, uh, one country and you are observing its GDP over 20 years. So you are trying to see the relationship between GDP and, say, petroleum prices, right? But it is only one country. There may be other countries also. And if you take the data for those countries also, and then if you take all the data into account for all the 20 years for many different 30, 40 countries, and then you see the relationship between GDP and petroleum prices, don't you think that now whatever results or conclusions you reach will be far more dependable and better explanation of the reality? I believe this is true. So panel data is rich in this sense, and panel data analysis, panel data contains more information. Another thing is more variability. So we saw in the assumptions of the classical linear regression model that we need variability in X values. So it is the panel data that gives us more variability. We can make use of it and reach at consistent results. There is less collinearity among variables. The reason is that even if two variables are collinear, they move together, but they will move together when it comes to different countries. What about if we are looking at it through time? They might not move together. So sometimes the two variables are collinear when you're looking over time, but when you see across countries, across states, across households, across villages, across states, they might not move together. So you are going to have less problem of multicollinearity in panel data. The last thing is more degrees of freedom and more efficiency. So of course, it is very difficult to have 100 years of data on a given variable, right? Because our data collection techniques have improved in the last 10-20 years. So how would you work with 20 observations? It's very difficult to work with such less number of observations. And when you are dealing with panel data, you are having not only 20 observations of a variable for a given country, but also 100 countries. That makes your number of observations more, and when you have more observations, you have more degrees of freedom to work with. You can do meaningful analysis with such amount of data, even though number of years is only 20. the, the last point here in the slide is that when you are when you are trying to see dynamics of change, right? Because panel data has a time dimension. Apart from being cross-sectional, it has a time dimension. So you are looking at unemployment, how it is changing over time, job turnover, labor mobility, how it is changing with time, and how it is changing across countries also, right? So it is wonderful to work with panel data with such a lot of room for understanding the relationships between different variables. You will also come across a few terms. I have written one or two in my slides, like balanced and unbalanced panel. So, suppose you have 10 firms and 20 years of data on each of the 10 firms on, say, 5 variables, right? It's a balanced panel, right? But if you have 10 firms and you have 20 years of data on firm 1 to 5, but 8 years of data on firm 6 to 9, and 25 years of data on firms 10 to 15, and then some other number of years of data on the remaining firms, it is an unbalanced panel. So unbalanced panel data have different challenges which can be addressed by some statistical techniques which you might learn in this. And dealing with balanced panels is rather easy and straightforward. Then we have terms like short and long panel. A short panel is when your subjects are more than the time period. Suppose you have 100, 200, 180 countries data, and it is just over 10 years of 10 time periods data, and there are 180 countries. So this is a short panel because the subjects are more than time periods. But if you have 10 countries data over 50 years of time, it's a long panel because you have more time periods than the number of subjects. So that's the difference between short panel and long panel, and the difference between balanced and unbalanced panel. Uh, uh, Panel data models, there are many of them. Just the very basic, which you would have heard a lot in literature, are the fixed effects and the random effects model. So there are slight subtle differences, and I would need to I would need a lot of time to make you understand these differences, at least 1 hour. But quickly, I think you will go through these models in this workshop. The pooled model, where you would disregard the time and subject specific nature of the data. You would pool all the observations into one column and then run your regression as if you are running a multiple regression in cross-sectional data. That would be the pooled OLS model. The fixed effects least squares dummy variable model is the one in which you allow for different intercepts for different subjects. The fixed effects model is the one in which you use mean corrected or demeaned values. The random effects model is the one in which you allow for only one particular fixed intercept, but you assume that these intercepts are a random drawing from a bigger population, and then the random part of the intercept goes into the error term. So error term in the random effects model is going to be a consolidated or it is made up of two parts: the idiosyncratic part and this random error part. So that's when you assume your differences in the intercepts to be such that they are a random drawing from a big population, and you can keep it in the error term. So there's this Hausman test to decide between these two models, and there are many more intermittent models where by making a few assumptions here and there, you can adjust your model and reach get the results that you want, which your resource persons will be talking later. One very last thing which I put here, because I know that this is something which is always there in panel data analysis: heterogeneity. So what is this heterogeneity? Actually, this is if you pool your observations disregarding the time nature and the space nature or cross sectional nature of your data, and you just put lump or dump all the values into one column and then run a pooled regression. The problem with that regression is that you subsume, or you don't take into account the individuality or uniqueness of the subjects, right? So it is very important to take into account that heterogeneity into account whenever you are doing a panel data analysis. That heterogeneity is nothing but subject specific characteristics which may be different for different subjects. When you pool the data, you disregard that, which is always there. So we must have methods that you will learn in panel data analysis which take into account this heterogeneity specifically, and uh, and then do the analysis. So that's it from my side. I think I finished in time, Dr. Biro. If any one of you have any question to ask, you feel please feel free to ask. Uh,
Yes, yes. Thank you, Dr. Faraz.
Thank you so
I
much.
think
Thank you so much.
you have given a uh, very good picture about this time series analysis as well as the panel. And I think this will boost our participants when they are going to participate in the analytical part using data. Then definitely they will have broader understanding of it. And thank you so much for giving so much light to the people, not the participants. I request if you have any doubt on it, please ask, and it will be like a 5 minutes interaction, question answer. And if not, then I think we'll wind up.
If you have
So
any question, any one of you, please feel free to ask.
yes, sir.
And I also request if you could switch on your video, okay? So we can see each other and find out who is maybe someone maybe known to us. Huh? So if you wish that you can switch on your video.
So I have the panel data. There I have two or three variables as like auditor type and district type, which is 0101 and dummy variable. So which method I should go? Actually, I'm going for the fixed effect model, but when I was running the data in EView, so the dummy variable problem showing with the multi-clonality problem. So how to deal with that? How to fix? So which model is appropriate? Is it a fixed effect model with this square variables? Please clarify it.
Okay. Actually, you can go with the fixed effects model and the random effects model both. The diagnostic checks should be there. There is no problem in running any of the panel data models on any of the data that you have. It's a question of which is more suitable. If you are having a problem in running the model, that means there is something with your placement of the data in the software, right? If you're having problem in running or getting the coefficients or getting the output, right? uh, the most important thing is that which one is better in a given circumstance, and that is done using Hausman test. If you want to select between fixed effects and random effects, if the Hausman test is significant, you can go with the fixed effects model. If the Hausman test is insignificant, go with the random effects model. So it's all about the assumption that we make regarding the error term, that we use the fixed effects and the random effects. Regarding running of the model in the software, I don't think there should be any problem in running both the fixed effect as well as random effects model for whatever panel data.
As you have, yeah. Sir, as you have mentioned your mail ID, can I share my data set with you and then you can tell that where is the problem in data setting?
Sure, I can, but you can do it later because you are having a session and an expert on panel data coming
Yes,
in
sir.
2 days' time. So I believe it will be great if you go through the session and learn it. And after that, of course, I've given the mail ID, and if any one of you want to ask anything to me directly, you can contact me later. But right now, your expert will be there. It will be great if you try to learn the analysis part, and then of course I will help you, no problem.
Okay. Thank you so much, sir. Thank you.
Anyone? Is there any doubt? Okay, fine. So I think
Hello. Just one more question, sir.
Yeah.
So I'm working on time series analysis, but few of my series are stationary by using ADF test on second level. But if I am applying PB test or KPSS test, they are showing that they are stationary at first difference. And what should I do? What should I consider? Whether these are stationary at second difference or should I take it for the first difference?
I believe again I would say that the whole time series analysis part is coming up, and you can ask the time series expert because they will be taking on these topics, the different models. I believe this will get clear in those time series sessions, right?
Okay. Okay. Thank you so much, sir.
Because here to explain this, it will be a little bit unfair on my part because there is a special guest who is coming and who will be talking about these things. So I never wanted to talk that much deep in analysis part of panel data or time series data or stata. Any general question if you have, you can ask.
so there is
Okay.
a
Thank you so
question
much,
like
sir.
what, sir?
Okay, yeah, there is a question here.
Uh,
Please, with example, let me know what is the difference between fixed effect model and random effect model. See, the difference between the two models, the fixed effect and the random effect, is with regard to your assumption regarding the error term. In fixed effect model, when if we assume that each subject will have a different intercept, right? So intercept will be fixed of a given value for each subject, and whether you are using the within group or between group estimators, that would be the fixed effect because intercept is fixed for each subject. Those are fixed effects. But when we assume that there is one single constant intercept in a model, and whatever the differences between the subjects with respect to intercept which are there, those differences are random pickings from a vast population of differences, so that differential part is added to the error term, right? So when this differential intercept part goes to the error term, your error term becomes a composite error term with very specific properties, which I am not discussing, of course, here. We need time to discuss the properties of the error term of a random effects model. So if you make that assumption, uh, and of course the correlation between the error term and the x variables is important. So there are proofs which tell us in what situations the error term and the x variables are going to be uh, uncorrelated, right? So if you make the second assumption, we go for random effects model. This is the basic difference between, in a layman's language, basic difference between random effects and fixed effects model. That's why the name random and the name fixed that appears in the name, right?
Yes. Anyone else? So with this, we conclude this today's session. And once again, I thank you. Start 2 o'clock tomorrow again. We'll be joining. And actually, this is the introduction section regarding data as well as the time series data and panel data in sense of econometrics or some. So therefore, tomorrow onwards, the real session is going to begin. So two experts, as you know, they are very good in data analysis in using data. So therefore, you should write so much of questions, means whatever the doubts you have, please ask them, get clarified. Okay, and try to reach on time so that you should not miss any one of these topics in between whatever happens. Basically, because there is a stepwise analysis when we go for time series as well as data, panel data, there is a stepwise analysis. For example, the stationarity check, you have to go for the first decoupled test or some other test will be given to you, or whether it is in the first attempt, whether if you are not getting stationarity, you have to go for the second test. So what is the criteria which makes you to go for the second test? So that all things will be given to you. So therefore, don't miss it, please, because with a lot of expectations, a lot of ambitious mind, we are organizing, and I thank all these participants. Till the end of the day, you should participate to get all the clarity. Second thing, we are not trying, we will be providing you all these PPTs, but I'm not sure whether we'll be able to give you the recording, but hope we will try to give you the recording. So with this, thank you, Dr. Faraj, and
Thank
I
you so
also
much.
thank you all the members, for those who have contributed for this workshop to be a successful one. Thank you. Thank you then.
Thank you so much, everyone. Thank you, each one of you. Thanks a lot.
Any queries, please
Have a good day.
write down to us, otherwise call us. Thank you. Just wait.